Here's integrated 3. It's problem 12-10. It's a system of equations. We have 3 equations with 3 unknowns. So here's the original that you start with, and the way that you do these is you can take 2 equations and eliminate one of the variables, and then take 2 other equations and eliminate that same variable, and then you're going to boil it down to a system of 2 equations with 2 unknowns, and then you can use substitution or elimination and solve it the way you normally do. This one, I like using elimination on these because it's already all lined up with the x's and then the y's and then the z's, and I see that the top equation and the middle equation, if I add them together, that the y's are going to cancel out. So I'm simply adding the x's together and I get 7x. The y's cancel out. The z's, if I add those together, I get negative 2z, and then the constant ends up being negative 1. So I'm showing that that's the y was eliminated from the first and second equation, and then I like to always just take the second and third equation. That way I can just draw it out horizontally like this. So I see I can use elimination again and get rid of the y's by multiplying the middle equation by 3. So I did a lot of this in my head, but you can pause the video if you want to work this out further. 3 times 5 is 15, and 15 plus 1, that's where my 16x came from. So I'm multiplying the middle equation by 3 and also adding it to the bottom equation. 3 times negative 1 is negative 3, and that cancels out with the positive 3. So the y's are gone. 3 times z is 3z minus 2z, that gives me just z, and then 3 times 11 is 33, plus negative 13 ends up being 20. So you can do that all on the side on scratch paper if you want. Now I've got 2 equations with 2 unknowns. I think it would be easiest to eliminate the z's by, if I multiply the second equation by 2, basically double everything and add the equations together. I'm going to again do that kind of in my head. I've got 2 times 16 is 32 plus 7 more. That gave me 39x. 2 times z is 2z, and when I add it to negative 2z, that canceled out the z's. 2 times 20 is 40. Subtract 1 is 39. So now I've got this equation. I just divide both sides by 39 and x equals 1. And then I'm going to plug x equals 1. I'm going to plug it into this 7x minus 2z equals negative 1. So I show all my work right here. You can pause the video if you need to, and it turns out that z equals 4. So I know x is 1, z is 4. Now I can just go try to find y, so I need to go back to one of these original ones. I used the top one. I plugged in 1 for x, and I plugged in 4 for z, and I solved it, and y was negative 2.